Lesson 4 in the matrices pack is how we use matrices to solve systems of equations. We're going to start by looking at 2 by 2, which are easy equations to solve. So 2 by 2 linear simultaneous equations. Obviously, these are easier to solve by hand, but when you get to bigger equations, you can use matrices to do so. And this will be how you calculate and solve equations for you. All right. We've got 2 simultaneous equations up here. You've got 2 methods of solving them. Either you could subtract and add the equations together to eliminate one of the variables, or you could substitute one to the other. But you can also represent these by the system of equations using a matrix. Okay. So if you have a vector xy, you put the elements, the coefficients of your equation, like these elements in this matrix. So 1, 2 along the top here. If you multiply that by xy, you would get 1x plus 2y, which is the first equation. And similarly, the bottom row, 1x minus y will give you 1. So you just read the equation across essentially. We can then use inverse matrices to solve these equations. So we could do the inverse of A on both sides. Notice it's on the left. And so our answer, xy, is equal to the inverse of that matrix, A times 10, 1. We can calculate this inverse. So the determinant of this is 1 times minus 1. And so 2, which is minus 3. And so the inverse of this is minus a third on the outside. Swap the elements of the leading diagonal and make the ones negative like this. Multiply this then by 10, 1. We do the first row times the column, so that's minus 10 minus 2, which is minus 12. Second row times the column, so minus 10 plus 1, this is minus 9. And if we times all these by minus a third, that gives us 4. So x equals 4 and y equals 3. The same as we got from doing it the traditional way. Now, obviously, for 2 by 2 matrices, this is overkill. This is not necessary to solve those. But as we start getting higher, 3 by 3 equations with x, y, z in, and you could do it for even higher, this is a much more efficient method. There is a question for you here, which you can have a go at before the video, and I'll reveal the answer in a couple of seconds. Now, extending these ideas to 3 unknowns, we can either solve these by elimination or we can solve them using matrices. Now, there will be occasions where you are required to solve 3 linear simultaneous equations and 3 unknowns by hand. So we will do this, but also we're going to look at using a matrix method for it. So to solve these 3 equations by elimination, we're going to first look to eliminate one of the variables x, y, or z. I'm going to eliminate z, although it doesn't really matter which one we do. So first off, I'm going to take equation 3 and subtract equation 1 so that I can cancel off the z's there. So I've got 3x minus 2 x, 5y minus y, or y. Minus z minus z cancels out and it's here. And you've got 0 minus 2, which you minus 2. I eliminate z in a different way, so now I'm going to include equation 2. So I'm going to do 3 times equation 1 plus equation 2, and that will eliminate z. So 3 times equation 1 gives me 6x plus x, which is 7x. 3 times equation 1, that's 3y plus minus 2y, which is y. That gives me minus 3z plus 3z cancels out, and that on the right hand side gives me 6 plus 7 gives me 13. So I have here now a pair of simultaneous equations in 2 unknowns in x and y. I'm going to use these to figure out what x and y are and then sub those back in to work out z. So if I do equation 4 times equation 5 minus equation 4, I will eliminate y. That gives me 28x minus x, 27x. The y's are eliminated. 4 times equation 5 gives me 52 minus 2, 4. This tells me that x is 2. Substituting this back into equation 1. So that equation 1, equation 4. So the x is 2, so 2 plus 4y plus minus 2, this will give you y is minus 1. Taking those two x and y's out and subbing those back into work out z, so let's put them back into equation 1. We'll get 2x, so 2 times 2 plus y minus 1 minus z plus 2. We can work out z from here. Almost like you said, equals 1. The x is 2, y is minus 1, and z. Yeah. It's not too bad, but lots of places that you can make mistakes. Now we can also do this using a matrix method. So I'm going to set up this matrix with the coefficients of my x, y, and z. It has to be in the same order, x, y, and z. This will be times by a vector including x, y, and z, and will be equal to the numbers on the other side. To solve this, I'm going to times by the inverse of this matrix on the left. It's really important that it's on the left. I'm not going to calculate this because it's a purely numerical matrix. All I'm going to write down, I'm doing this to the minus 1 times by 270, and then this is the calculation that I'm going to do in my calculator. So F4 for math, F1 for math vector, putting you 3 by 3. This to the power minus 1 for the inverse, and then times this by 3 by 1, 2, 0, which will give me the answer. Much faster than solving it by hand by elimination. Obviously, your calculator has an equation solver on it, but if they're asking you to solve this using a matrix method, this is the steps that they want to see. If it's purely numerical, there's no need for you to calculate the inverse, and you can literally just type into calculate and write down the answers. Have a go at the following question, and pause the video and I'll reveal the answer in a couple of seconds. In this solution, they have calculated the inverse and written it down, but there's no need for you to do that. You literally can just write the matrix to the power minus 1 and get your answers. Minus 1, 4, 2. Notice the amount was x equals y equals z equals at the end, which is good practice to do to make sure you get all of them. So in your exam, you may also get asked about questions in context. There are a couple of exam technique bits that you need to know about for this. First off, you must define your variables before you answer this question. So in this question, we've got 1,000 mole rats made up of adult males, adult females, and youngsters. I'm going to assign x, y, z to each of these, but I must write this out. So I've got to write out that x equals number of males. Originally, y equals the number of females. And z equals the number youngsters originally. There will be a mark for this. Then we have to take the information given to us in the question and form some equations. So first off, we've got 1,000 mole rats. So the total population of the mole rats is equal to 1,000 x plus y plus z. It then says there were originally 100 more adult females than adult males. So I'm going to do this as subtraction. The difference between the adult females and the adult males is equal to 100. There are other ways you could do it. You could say the number of adult females is equal to the adult males plus 100, but ultimately you need to rearrange it so you've got x and y on the same side. And actually, I'm going to swap the order of these just so it's in the right order. So minus x plus 1. Then you've also got all this information here. So it says after 1 year, The number of adult males has increased by 2%, so times by multiplied 1.02. The number of adult females has increased by 3%, so times by 1.03. The number of youngsters has decreased by 4%, so times by 0.96. And the overall population has decreased by 20, so take 20 away from 1,000 people. We can set this up as a matrix multiplication form from the coefficients of our equations. So we've got 1, 1, 1 along the top. The middle row, we've got minus 1x plus y, 0 for z, and then on the bottom, we've got 1.02, 1.03, 0.96. This is all times by x, y, z, and equals vector of 1,000. Now, it doesn't actually matter which order you put these equations in, as long as you're consistent with where the answers go. The calculation we're going to do is just times in by the inverse on the left. That's out. It's a minus 1 times by 1,080. And then we're going to do this calculation. So map vector by now 3 by 3. 1. Minus 2. 2 about minus 1 for the inverse. Oops, not there. And times by 3 by 1 matrix of 1,000. So we get, looking like a good answer, 102 instead of 100. Nice numbers. It's not enough to write your answer like that. You must write it in context. So you must write, therefore, there were 100 adult males. 200 adult females. 700 youngsters. Or something like that, but you've got it right in the context of the question. Pause the video now, have a go at the question for you, and I will reveal the answer in a few seconds.